The human brain, a 3-pound universe within our skulls, is often shrouded in mystery. One of the most pervasive myths surrounding this complex organ is the idea that we only use 10% of its potential. This notion, often perpetuated by popular culture, suggests that unlocking the remaining 90% could lead to extraordinary abilities. However, this belief is nothing more than a fallacy. Scientific evidence overwhelmingly debunks this myth. Brain imaging techniques such as functional magnetic resonance imaging or fMRI clearly demonstrate that even simple tasks engage multiple areas of the brain. From brushing our teeth to solving complex equations, our brains are constantly buzzing with activity. The idea that a vast portion of our brain lies dormant is simply incompatible with our understanding of evolution and neurology. The human brain is an energy-hungry organ, consuming a significant portion of our daily caloric intake. It would be highly inefficient for such a metabolically expensive organ to have evolved with such a large proportion remaining unused. The reality is that we utilize all parts of our brain, albeit not all at once. Different brain regions have specialized functions, working in concert to orchestrate our thoughts, emotions, and actions. The origins of the 10% brain myth are shrouded in speculation, with several potential sources emerging throughout history. One theory points to misinterpretations of early brain research. In the late 19th and early 20th centuries, scientists were just beginning to understand the brain's complexity. They discovered that only a small percentage of brain cells, neurons, were firing at any given time. This finding, however, was misconstrued to mean that the remaining neurons were inactive or dormant. Another possible source is the work of psychologist William James, who, in his 1908 book The Energies of Men, suggested that humans only use a fraction of their mental and physical resources. While his statement was not specifically about brain capacity, it may have been misinterpreted and contributed to the spread of the myth. The myth gained further traction through self-help gurus and motivational speakers who exploited the idea to sell their programs. They promised to unlock hidden potential and unleash superhuman abilities by tapping into this supposedly untapped reservoir of brain power. Despite its lack of scientific basis, the 10% brain myth has persisted in popular culture, featuring prominently in films, television shows, and books. This perpetuation likely stems from the allure of the extraordinary. The idea that we possess untapped potential is inherently appealing, offering a tantalizing glimpse into what we might be capable of achieving. To understand why the 10% brain myth is false, we need to appreciate how the brain operates. The brain is not a collection of isolated compartments, each responsible for a single function. Instead, it is a highly interconnected network of billions of neurons that communicate through trillions of synapses. Imagine a bustling city, with information flowing constantly through a complex network of roads, bridges, and tunnels. This is akin to the activity within our brains, with electrical and chemical signals constantly being transmitted between neurons. Even when we are at rest, our brains are far from idle. This baseline activity, known as the default mode network, is responsible for important functions such as memory consolidation and self-reflection. Brain imaging studies have consistently shown that even seemingly simple tasks activate multiple areas of the brain. For instance, reading this sentence involves the visual cortex to process the words, the language centers to decode their meaning, and the frontal lobes to integrate the information and form thoughts. The brain operates on the principle of efficiency. It constantly optimizes its activity, strengthening connections that are frequently used and pruning those that are not. This process, known as synaptic plasticity, ensures that our brains are adaptable and constantly learning. While the entire brain works in concert, different regions have specialized functions. The cerebral cortex, the outermost layer of the brain, is responsible for higher-level cognitive functions, including language, memory, and reasoning. The frontal lobes, located at the front of the brain, are crucial for planning, decision-making, and executive function. The parietal lobes, behind the frontal lobes, process sensory information from the body, including touch, temperature, and pain. The temporal lobes, situated on the sides of the brain, are involved in auditory processing, language comprehension, and memory formation. The occipital lobes, at the back of the brain, are responsible for visual processing. Beneath the cortex lie structures that regulate essential functions such as breathing, heart rate, and sleep-wake cycles. For example, the cerebellum, located at the back of the brain, coordinates movement and balance, while the hippocampus, deep within the temporal lobe, plays a crucial role in memory formation. Section 5. The Daily Grind: How Our Brains Navigate Everyday Life. Throughout the day, our brains seamlessly orchestrate a myriad of tasks, from the mundane to the complex. Consider the simple act of walking. This seemingly effortless action requires input from multiple brain regions, including the motor cortex to control muscle movements, the cerebellum to maintain balance, and the visual cortex to process visual cues from the environment. Now imagine engaging in a conversation. This requires not only language processing but also the ability to interpret social cues, understand emotional nuances, and formulate appropriate responses. All of this occurs in milliseconds, highlighting the remarkable efficiency and complexity of our brains. Even when we are asleep, our brains are hard at work, consolidating memories, clearing waste products, and preparing us for the day ahead. The brain is a truly 24/7 organ, constantly adapting to our internal and external environments. The human brain, while only accounting for about 2% of our body weight, consumes a disproportionate amount of energy. In fact, it accounts for approximately 20% of our total energy expenditure. This high energy demand reflects the brain's constant activity, even when we are at rest. Glucose, a type of sugar, is the primary fuel source for the brain. It is transported to the brain via the bloodstream, where it is metabolized to produce energy. This energy is essential for maintaining the electrical gradients across neuron membranes, which are necessary for communication between neurons. The brain's high energy demand also means that it is particularly vulnerable to disruptions in energy supply. For example, during a stroke, a blood clot can block an artery supplying blood to the brain, leading to a shortage of oxygen and glucose. This can result in permanent damage to brain cells and loss of function. The 10% brain myth often goes hand in hand with other misconceptions about the brain. One such misconception is that people are either left-brained or right-brained, with the left hemisphere responsible for logic and the right hemisphere responsible for creativity. While it is true that the two hemispheres have slightly different specializations, they are in constant communication and work together to perform most tasks. Another misconception is that brain training games can significantly boost intelligence. While these games can improve specific cognitive skills, such as memory or attention, there is no evidence to suggest that they can increase overall intelligence. Intelligence is a complex trait influenced by a multitude of factors, including genetics, environment, and education. It is also important to note that brain damage can have devastating consequences, further undermining the notion that we only use a small portion of our brains. Even small lesions can result in significant impairments in language, memory, or motor function. One of the most remarkable aspects of the human brain is its plasticity, its ability to change and adapt throughout life. This plasticity is evident in the brain's ability to recover from injury, learn new skills, and form new memories. Synaptic plasticity, the strengthening and weakening of connections between neurons, is a key mechanism underlying brain plasticity. When we learn something new, the connections between neurons involved in that task are strengthened. Conversely, when we stop using certain connections, they weaken and may eventually be pruned. This remarkable adaptability is what allows us to adapt to new environments, learn new languages, and recover from stroke or traumatic brain injury. While the brain's plasticity does decline with age, it never completely disappears, meaning that we retain the capacity for learning and growth throughout our lives. The 10% brain myth, while alluring, is ultimately a fallacy. Our brains are constantly active, orchestrating our every thought, feeling, and action. While we may not be using 100% of our brains all at once, we utilize all parts of our brains over the course of a day. The true potential of the human brain lies not in unlocking some mythical unused portion, but in fully embracing the remarkable capabilities we already possess. By nurturing our curiosity, engaging in challenging activities, and seeking out new experiences, we can continue to learn, grow, and unlock our full potential throughout our lives. The human brain is a testament to the power of evolution, a complex and adaptable organ capable of extraordinary feats. Rather than focusing on a fictitious limit, we should marvel at the incredible capabilities we already possess and strive to use them to their fullest.